Thanks for this great opportunity. And today I want to show you my results on the heritability analysis on human corpus callosum microstructure. The heritability is defined as a proportion of phenotypic variation that can be explained by the genetic factors. And now, many MR studies have focused on the heritability of multiple brain phenotypes, including cortical thickness, surface area, and brain volumes. The corpus callosum is the largest white matter in human brain and is important for the information communication between the two hemispheres. And its structure and function has been widely studied by using the both healthy and disease cohort. The heritability of corpus callosum is reported to be high on its structure measures, including area, height, length, and white matter density. But so far, only a few studies have focused on the microstructure properties of this area using DTI measures. Although these measures are widely used to indicate the microstructure properties, they are not specific enough to for the different tissue microstructure properties. So more recently, the Nordic method provides us two fine-grained diffusion measures, that is the FICVF and ODI. The FICVF is the intracellular volume fraction, which estimates the neurite density, while ODI is orientation dispersion index, which can reflect the angular variation of neurites. So here in the study, we focused on these two Nordic measures along with FA, and we performed the voxel-based heritability analysis on the mid-sagittal corpus callosum. And we further looked into the relationship between the phenotypes and their heritabilities. These phenotypes here are the three diffusion measures. The twins data we used here is supported by the Human Connectome project, and we used the 900 subject data release. The diffusion MRI here has 3 B-value shells, so we can perform the Nordic method on it. Then we calculate the 3 diffusion measures, FA, FSVF, and ODI, and then normalize them to the MR space, and then smoothed. The segmentation of the corpus callosum is done by UK module in the ART software in the MR space, and then the segmented CC structure was subdivided into 7 subregions according to Watson scheme. Then we estimate the heritability at each voxels within the CC area, and well controlled for several covariates in our analysis. So for the results part, here is the group average maps for the 3 diffusion measures. And we can see from the picture that we found the high FA value and the low ODI value, which is caused by the axons in the mid-sagittal area is highly aligned in some direction. And we also found the high FSVF value, which may reflect the extremely dense fiber nerves in this area. Here is the heritability results, and we found that the two Nordic measures showed relatively higher heritability than FA, and the parity test further confirmed our observation. And we can also see from the figure that the body parts showed relatively lower heritability for these 3 measures than the anterior and posterior parts. So we looked into the heritability in the subregions, and we found Still, we found the mid body of the CC structure showed a relatively lower heritability and are less influenced by the genetic factors. This this body parts of CC are mainly connected to the primary motor and sensory cortices, which need to adapt to the varying sensory experience and motor activities during daily life. So this may be the reason why this part of CC have lower heritability and more influenced by the environment factors. So then we conducted a spatial correlation between the mean maps and the heritability maps. And we found a significant correlation in FA and ODIF, but not in FSCVF. This correlation means that the degree of heritability is related to the phenotype value itself. For instance, the negative correlation in ODI means that a voxel with a more dispersed fiber structure will be less influenced by the genetic factors. So in the summary, we found a spatial-specific genetic control on the mid-sagittal CC microstructure, and this may help us to understand the genetic influence on this structure and its connected cortex and their functions. And more importantly, we found that the degree of heritability was associated with the trait value itself. And I think future work will focus on this relationship and to find how will this relationship changes during development or aging or under disease states. And finally, we found a higher heritability in the two Naudi measures than FA. One reason for this may be that these two Naudi measures can disentangle the key macrostructure factors that contributing to FA. So thus these two measures are more specific and more sensitive to investigate the genetic influence. Some ideas for future work. First point is that the interaction between genes and the environment may influence the phenotype rather than separately. So future work should take this type of complication into account. And secondly, actually we found a highly correlation between these three diffusion measures. So I think the genetic correlation analysis should be done to clarify their shared genetic basis. And since HCP also provide us the genotyping data, we can use this SNP information to estimate the heritability and validate our results. So finally, I'd like to thank my supervisor, Professor Gong, and to thank all the members in our lab. So thanks for your attention.